online. So if you go and you find simplifying radicals 2, then you'll see that the document you download actually does have the answers. So half of this is review of what we did yesterday. The rest of it is going to be new. And I lost my paper. So, to simplify root 12, I'm going to factor into 3 and 4, 2 and 2. I'm looking for pairs. I have a pair of 2's, so I bring out a 2, and that 3 is left over, so the answer would be 2 root 3. Factoring 8, we have 4 and 2, 2 and 2. Again, I have a pair of 2's. 2 root 2 would be my answer. For number 3, 9 is a perfect square. It's 3 and 3. I circle the 3's and I write 3. What's left on the inside? Nothing, as in, what number is nothing? 0 or 1? What, 1? I have 1 fake marker in my hand. Is that nothing? Is it 1 or 0? Well, you know it's a 1, but you're kind of hung up on this idea of nothing. Nothing in mathematics is the number that doesn't change anything. So if we're looking at addition, 0 is nothing. It's called the identity. 0 plus anything is that anything. But for multiplication, 1 is the number that does nothing. So there's nothing left on the inside, but we're talking about multiplication. So it's actually 3 times the square root of 1, but the square root of 1 is 1, and 1 times 3 is 3. So we can just ignore our nothing. Good? Number 4. Can anybody look at number 4 and figure out what we want to pull out without factoring it? We're looking for a perfect square. What is the biggest perfect square that goes into 20? 4. Why? Oh, okay. You're just over there making noises? Okay. Good to know. Next time I'll ignore it. Smile, you're on camera. The biggest perfect square that is a factor of 20 is 4. So if I pull out that 4 and square root it, I get 2. 2 square root of 5. Anybody want to guess what the biggest perfect square inside 180 is? Well, I know that 4 works, right? And I know that 9 works, because 9 goes into 18, and 180 is just 18 times 10. So 4 and 9 work, so 36 must work, but there might be a bigger one. So we're going to have to factor it. My guess will be 36, but we'll find out. 18 and 10, 6 and 3, 2 and 5, 2 and 3. And I have a set of 3's and a set of 2's. So I'm going to pull out a 6 with the 5 left over. 6 root 5. How many of you got the worksheet totally done last night? You guys are amazing. Right on. All right. Biggest perfect square that goes into 500. This one's easy. 10 times 10. 100 goes into it. But if 100 goes into it, what's the other factor? 5. So this is 100 root 100 times root 5, which is just going to be 10 root 5. So sometimes they're really easy. If we factored it out, we would have got 50 and 10, 5 and 10, 2 and 5, 2 and 5, set of 2s, set of 5s, so we bring out a 10 with a 5 left over. Now we're going to move on to multiplying and adding roots. Yes. Yeah, turn that in. You can wait. I mean, you can wait. But yeah, turn it in before you leave. Okay. How do we simplify number 7? Right, 2 times 3 is 6, so it's just the square root of 6. Why is that allowed? You're half right. They are both radicals, but that's not enough. Well, some will be able to be simplified and you can still multiply them. Okay, I'm not being very good in asking my question. Is it possible that two radicals cannot multiply together? Everything on this page can, because they're all square roots. Yeah. If you had a square root and a cubed root, you could not put them together. How come? So what's really happening here is 2 raised to the 1/2 times 3 raised to the 1/2. Well, I can factor out that 1/2 power. So I can pull this 1/2 power out, and I get 2 times 3 to the 1/2 power. But what if I had the square root of 2 and the cubed root of 3? Then I would have 2 to the 1/2 times 3 to the 1/3, and I'm totally stuck. If the bases were the same, I could put them together. But since the bases are not the same, I can't add these, and I can't pull them out because they're two different numbers, so this one would not be able to be simplified at all. So in order to multiply two radicals, the inside numbers don't have to be the same, but the exponents or the roots have to be the same. Number 8, we can do the same thing. Square root of 35. Will that simplify? How do I know? 5 and 7 are prime. They have no common factors, so there's no point in factoring this. All right? Number 9, I get the square root of 18. Will that simplify? Why? Oh, okay. What can I pull out of this? What perfect square is inside 18? 9. So I could factor this and get 3 and 6, 2 and 3, and I share some 3's, so it would be 3 root 2. But it's sort of a waste of energy to create the 18 and then to break it down, right? So you could just factor this and see, oh, I'm going to put these together anyway, so there's my set of 3's, and save yourself a step. Because I know they're all going to combine together, and then I'm going to break it down and try to factor it. So you might as well break them down before you put them together and save yourself a little bit of a headache. So number 10, 5 and 3, I have a set of 5's, so I get 5 square root of 3. Is this making sense? Okay. What about number 11? Okay, so when you say numbers, I see 4 different numbers. What do I do with the ones outside? What do I do with the ones inside? If you added them, then it would be nothing. But we're multiplying. So you multiply the outside numbers and you multiply the inside numbers. So 6 times 4 is 24 times the square root of 25. Well, what is the square root of 25? 5. What do I do with that 5? Times it by 24, and I'm going to guess that that's going to be 120. So it's actually 120. So you multiply the outside numbers, you multiply the inside numbers, and then you try to simplify the inside if possible. So Tegan is suggesting, why don't I just consider these? So those will create a 5 on the outside, and then do 6 times 4 times 5. That would work. Is that what you meant? Yeah, you can do the insides and figure out what comes out, and then multiply that by everything on the outside. And the inside usually isn't going to disappear. Like in number 13, the inside will not disappear. So let's do that one. So I'm going to have 3 times 4, 3, 2, 2, 3, and 3. What can I pull out? Set of 3s and a set of 2s. So on the outside, I have my original 3 times 2 times 3 times what's left. So I used the outside 3, I pulled out a set of 2s, I pulled out a set of 3s. Radical 3. So that would be 6 times 3 is 18 root 3. The 4 factors, so we can ignore it. The 4 became 2 times 2. All right, I'm going to leave some of those for you to do. Let's go down to number 16. In order to add 2 radicals together, they have to be the same root, and they have to have the same number on the inside. Just like saying, if I had 2x squared, can I add that to 3x? They're the same variable, right? Yes, but they have different powers. Okay? What if I had 2x squared plus 3y squared? Can I add those together? No. They're the same power, but they're not the same variable. So in order to add variables together, I would have to have 2x squared plus 3x squared. What do I get there? 5. So I added my 2 and my 3. And it's still x squared. How come? Addition doesn't change the variable. It just changes how many of them you have. I had a pair of x squareds and a triple of x squareds. Now I have 5 x squareds. If you add 4 apples and 4 apples, you don't get 8 of something different. They're still apples. So in order to add square roots, if I had the square root of 3 plus the third root of 3, that won't work. Even though they're both 3's, they have different exponents. And the exponents and the base have to be the same. Likewise, if I had the square root of 3 and the square root of 2, those have the same exponents, but they do not have the same bases, so you cannot add them together. So in order to add radicals, you'd have to have root 3 plus root 3, which would give me root 6, root 9. What would that be? What is x squared plus x squared? 2x squared. If we're adding them, we just count how many there are. So this is just going to be 2 root 3. It doesn't change the value of the radical. That will not change in addition. The only thing that changes is the coefficient, which tells you how many there are, according to addition. So number 16, if I have 2 root 5 plus 7 root 5, then I would end up with 9 root 5. Okay, let's do 18. 8 root 7 minus 3 root 7. 5 root 7. 7. Okay, look at number 21. Can I combine the values in 21? I might be able to, but we need to simplify first to tell. So 5 root 2 is already simplified. So 9 and 2, 3 and 3. So root 18 becomes 3 root 2 plus 5 root 2 gives me 8 root 2. Good. Your assignment today is to finish that worksheet, and I want you to do wrong one. I want you to do pages 18 and 19 out of the textbook. So page 18 and 19, and finish that worksheet that you're working on now.